When you look at a college curriculum, it can just seem like a list of classes, right? Well, today we're going to do something a little different. We're looking at the final semester for a computer science diploma, but we're not just going to read a list. We're going to treat this as the blueprint, the final assembly instructions for creating a modern tech pro. All right, so let's jump right in. What you're looking at here is the actual course list, and it's a really interesting mix, isn't it? You've got stuff like e-commerce and AI. That's the shiny, user-facing stuff we all see and touch every day. But then right alongside it, you have microprocessors and cyber law. That's the deep stuff, right? The actual hardware and the legal rules that everything has to play by. So you can see this isn't just a random grab bag of subjects. It's a really deliberate, carefully chosen toolkit designed to build a technologist who understands the entire stack, from the silicon all the way up to the screen. Okay, so first up, let's talk about the part of the tech world we all know best, the digital marketplace. Think about all the online shopping we do. We're going to break down how these students learn to build all of it, not just the storefront, but also those spooky smart recommendation engines that, well, they kind of feel like they're reading your mind, right? Think about it. That Buy Now button. We click it all the time without a second thought, don't we? But what actually happens behind the scenes? Well, there's a huge, complex world powering that single click. And that's exactly what this e-commerce course is all about. It pulls back the curtain and teaches students how to build that entire engine from the ground up. And this engine, it really has two main flavors. First, there's B2C, or business to consumer. That's the one we're all familiar with, right? It's your Amazon, your eBay, the whole online shopping experience. But then there's the other side of the coin, B2B, or business to business. Now, this is the invisible giant, the hidden backbone of how pretty much everything gets made and sold. It's all about how companies do business with each other. They learn about tech like EDI. That's electronic data interchange. Just think of EDI as a special, standardized language that lets a company's computer talk directly to a supplier's computer. It handles orders, invoices, payments, all automatically. No humans needed. It's kind of the secret sauce of the modern supply chain. Okay, so you've built the store. It works. But how do you make it smart? How does it get so personal that it knows exactly what you might want to buy next? Well, that's our next topic. We're moving from just building the store to giving that store a brain. And yep, you guessed it, we're diving into artificial intelligence. So the AI course gives students this amazing problem-solving toolkit. A huge part of that is something called search. And no, I don't mean Googling something. This is about how a program finds the best answer to a problem. They learn a few different ways to do it. First, you've got your uniform searches. Think of this like exploring every single hallway in a maze one by one. It's super thorough, but man, it can be slow. Then they learn heuristic searches. This is the clever way. It uses smart shortcuts or rules of thumb to find a good solution fast. Your GPS is a perfect example. It doesn't check every single road in the world, right? It uses heuristics to find the fastest route. And finally, there's adversarial search. This is the fun one. It's all about planning for an opponent's moves, like in a game of chess. It's thinking, if I do this, what will they do? This whole toolkit of searching is the basic logic behind, well, pretty much everything, from your Netflix recommendations to a computer that can beat a grandmaster at chess. All right, so we've got a smart online store. Fantastic. But what's it all running on? What's holding it all together? It's time to pop the hood and look at the engine. Because a real technologist can't just be a good driver. They need to be a mechanic. They have to understand the invisible foundations, the actual hardware and the core code that make everything tick. And that brings us to the microprocessor course. Here, students get down to the absolute most fundamental level of a computer, the machine cycle. It's this tiny four-step dance: fetch, decode, execute, store. And get this, it happens billions of times a second. It is quite literally the heartbeat of your phone, your laptop, every single digital device you own. Understanding this is like a master mechanic understanding exactly how a piston fires in an engine. Okay, now for the FOSS course. That's free and open source software. And this one clears up something a lot of people get mixed up. Free software and open source software. They sound the same, but they're not. Free in this case doesn't mean free of charge, like a free beer. It means free as in freedom. It's a philosophy about your right to run, copy, and even change the software yourself. Open source, though, is a bit more practical. It's more of a development style that's all about the benefits of having the code out in the open for anyone to see, leading to better collaboration and transparency. And trust me, this isn't just academic. This difference in philosophy is a huge deal. It shapes the entire culture and the legal rules for massive projects you use every day. like Linux and the Android operating system. So you've written all this amazing code. How do you make sure it's not a buggy mess? That's where software testing comes in. Students learn this really rigorous, layered approach. Think of it like building a pyramid of quality control. At the very bottom, you've got unit testing. You're just testing the tiniest little bricks of code to make sure they're solid. Then you move up to integration testing, where you check if those bricks fit together nicely. After that, system testing, where you're looking at the whole pyramid to make sure it stands up. Then acceptance testing. Does the customer actually like the pyramid we built? And maybe most important of all, regression testing. This is where if you add a new pointy bit to the top, you recheck the whole thing to make sure you didn't just make the base crumble. It's all about systematically hunting down bugs to make sure the final product is rock solid. Okay, so we've got our app, and it's running on a solid foundation. But here's the thing. Technology doesn't just exist in a digital vacuum, right? It's built by people, for people, in a world that has laws and budgets and deadlines. And that's exactly where we're headed next. We're going to look at the human side of things, the rules of the road for our digital world, and the skills you need to take a cool idea and actually make it happen. And check out this quote. This comes straight from the Cyber Law and Security course outline, and wow, it really gets to the point, doesn't it? Dealing with frauds and deceptions, scams, and other cybercrimes. This tells you right away, this class isn't just about abstract legal theory. It's about getting these students ready to face the very real, very serious threats that exist online. They're learning about everything from how to protect data and use digital signatures to the actual legal tools we have to fight back against cybercrime. And this right here, this is how a spark of an idea actually becomes a real thing. The project management course gives them a roadmap, a structured life cycle for getting things done. They learn how to plan everything out using these pro-level tools. You might have heard of them, CPM and PERT charts. They're basically super detailed maps for complex projects that show what needs to happen and when. But it's not just about planning. They also learn how to manage resources, people and money, and even how to figure out if an idea is worth pursuing in the first place with a feasibility study. And of course, they learn how to monitor the whole process to keep it on track and on budget. This is the playbook for turning a concept into a reality. So, let's recap. We've talked about building the stuff we see, securing the foundations underneath, and understanding the rules of the game. Now for the final piece of the puzzle, and maybe the most important one. This is about taking all that knowledge and hammering it into real, practical, job-ready skills. This is the moment a student really becomes a pro. And this is where it all comes together. Think of these as the final exams, the boss levels. Each one tests a totally different skill. You've got the hardware lab that's all about hands-on skill. Can you actually assemble a PC, install an OS, and figure out what's wrong when it breaks? Then you have Project I. This is the creative test. Can you take everything you've learned from all your classes and build something real and functional? And then there's the Grand Viva. This is the final showdown. It's a comprehensive knowledge defense where you have to prove you don't just know facts, but that you truly understand the why behind it all. And that's it. The blueprint is complete. From the tiniest machine cycle to the global laws that shape the internet, these students now have the full toolkit. They're officially equipped and ready to go out there and build the next chapter of our digital world. So the only question that's really left is, what are they going to build next?